Hello, this is Mrs. Ward, and I'm going to go over the classwork for section 5.4, sum and difference formulas. So just a reminder, we will always give you those formulas. You are not expected to remember them, so they will be there. So for the first one you were given was 3a, so you're trying to find the cosine of cosine of pi over 4 plus pi over 3. So I'm using the sum formula for cosine, so I'm using this formula right here. So I'm going to say the cosine of pi over 4 times the cosine of pi over 3 minus the sine of pi over 4 times the sine of pi over 3. So when I do that, I'm going to say the cosine of pi over 4 is the square of 2 over 2. The cosine of pi over 3 is 1/2 minus the sine of pi over 4 is the square of 2 over 2. The sine of pi over 3 is the square root of 3 over 2. So when I do this, I'm going to have the square root of 2 over 4 minus the square root of 6 over 4. So that'll be the square root of 2 minus the square root of 6 all over 4. So that was 3a. Then to do 3b, they want the cosine. I'm going to switch colors here. B, they want the cosine of pi over 4 plus the cosine of pi over 3. So the cosine of pi over 3 is the square root of 2 over 2. The cosine of pi over 3 is 1/2. They have the same denominator, so that's going to be the square root of 2 plus 1 all over 2. They are not the same because it matters whether I take the addition first, then do the cosine, or take the cosine first and then do the addition. Order of operations matters, is I guess what I'm trying to say. Okay, 8a, I take 165 degrees, and I am going to split it into 135 and 30. And just a quick note, the directions here, you are only doing the sine and cosine. You are not doing the tangent. So when I go to do 165, let's do the sine first. So I'll do the sine of 135 times the cosine of 30 plus the cosine of 135 times the sine of 30. So the sine of 135 degrees is a positive square root of 2 over 2. The cosine of 30 degrees is square root of 3 over 2. Plus the cosine of 135 degrees is going to be a negative square root of 2 over 2 because it's in the second quadrant. And the sine will be 1/2. So when I do this, the common denominator is going to be 4. So I'm going to end up with the square root of 6 minus the square root of 2 all over 4. That is number 8. Then to do the next one you had to do was number 16. I want 15 degrees. They didn't separate 15 degrees, but I'm going to separate it as 45 degrees minus 30. Remember, there's different ways that you can separate it, but that's the way I'm going to think of it. So, oh, my bad, 8. I forgot to find the cosine. This is the sine of 165 degrees. Now I have to find the cosine of 165 degrees. And to do that, I'm going to use the cosine addition formula. So I'm going to do the cosine of 135 degrees times the cosine of 30 degrees. Change the sign, minus the sine of 135 degrees, sine of 30 degrees. The cosine of 135 degrees is negative square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2, minus the sine, which is the square root of 2 over 2, times sine of which is 1/2. So when I do that, I end up with a negative square root of 6 minus the square root of 2, and this is going to all be over 4. Okay, so now back to 16. I'm doing the sine of 15 degrees. So remember, I'm using 45 minus 30, so I'm using the subtraction formula. So I'm going to say the sine of 45 degrees, cosine of 30, and then this will be minus the cosine of 45 degrees, sine of 30 degrees. Whoopsie, I'm getting kind of messy. So the sine is the square root of 2 over 2. The cosine is the square root of 3 over 2, minus the cosine, which is the square root of 2 over 2. the sine, which is 1/2. So I end up with the square root of 6 minus the square root of 2 all over 4. That's the sine. To do the cosine, I'm going to do the cosine of 15 degrees. So remember, I'm thinking that as the cosine of 45 degrees minus 30 degrees. So I'm using the difference formula. So I'm going to say the cosine of 45 degrees times the cosine of 30 plus the sine of 45 degrees sine of 30. Using the difference formula, just checking to make sure I did it right, which I did. Square root of 2 over 2 times the square root of 3 over 2 plus the square root of 2 over 2 sine of 1/2. So I end up with the square root of 6 plus the square root of 2 all over 4. And that was number 16. And the last one is 5 pi over 12. I can do it as a radian, but if I'm not comfortable with the radian, I'm going to go ahead and change 5 pi over 12 into degrees. So here's number 20. I have 5 pi over 12, so I'm going to change it to degrees. To change it to degrees, I'm multiplying by 180 and dividing it by pi. So I ended up with 75 degrees when I did that. So I have choices how I'm going to get to 75 degrees. I can do 135 minus 60 to get 75, but the first one I thought of was the 45 plus 30, so that's what I'm going to do. So the sine of 75 degrees is going to be equal to the sine of 45 degrees plus 30 degrees. And remember, it doesn't matter the order that I write those two in. So to do the sine formula, I'm going to do the sine of 45, cosine of 30, plus cosine of 45, sine of 30. So square root of 2 over 2, square root of 3 over 2, square root of 2 over 2, 1/2. So I end up with the square root of 6 plus the square root of 2 all over 4. That is for the sine. For the cosine, I am going to do cosine of 75 degrees will be the cosine of 45 plus 30. And I don't have to go back and change these to radians because this is just a point in my work. So I don't need to go back and change it to radians because this is just me helping me do the problem. This is my final answer, and it doesn't matter how I got there, whether I was in radians or degrees. I thought I'd just tell you that. Cosine of 45 degrees times the cosine of 30 degrees minus the sine of 45 degrees cosine of 30 degrees. Whoopsie, barely squeeze that in. Square root of 2 over 2, square root of 3 over 2, minus square root of 2 over 2, 1/2. So I end up with the square root of 6 minus the square root of 2 all over 4. So those are my answers for sine and cosine. The next one is it wants me to write the expression as a sine, cosine of an angle. So what I look here, and I'm trying to take 60 and 20 and I'm either subtracting 60 and 20 or I'm adding 60 and 20, and then I'm trying to figure out which trig function I'm trying to find. So the first thing I look at is I have cosine, cosine, sine, sine. So I'm doing one of these, cosine, cosine, sine, sine. So I know I'm doing the cosine. And then I have my two angles, which are going to be 60 and 20. That's my U and my V. I just have to decide whether I'm adding or subtracting. If I have this minus sign here, that means I really added those two angles. So I'm going to have plus. So this will end up being the cosine of 80 degrees. It's not asking me to find it. It's just asking me to write it as the expression of sine, cosine, or tangent, but we're not doing tangent. Okay, I'm looking at number 30. This one goes sine, cosine, cosine, sine. So I know it has to be a sine value. I'm looking for that. So I know it's going to be sine. My two angles are 4 pi over 9. And my other angle is pi over 8. And then I have this plus sign here. And cosine, when I have the plus sign, that means I'm adding those angles. So I'm going to add those two angles. So I'm going to add those 32, 9, 41 pi over 72, I believe. Gee, I hope I did that right. I added those two. If you're not a fan of fractions, you're taking 4/9 plus 1/8 on your calculator, and you're going to add the pi later. And I'm going to pause to make sure I did. Good news, I did it right. Good for me. So moving on. This one I have, it says find the exact value of the trigonometric functions given that the sine of u is equal to 5/13, the cosine is equal to -3/5. Both u and v are in quadrant 2. So the first thing I'm going to do is I'm going to draw a triangle. So this will be my triangle for u. It tells me that the triangle's in the second quadrant, so I'm going to draw it in the second quadrant. My sine is the opposite over hypotenuse. When I do Pythagorean theorem, I'm going to find out that this, when I do 13 squared is equal to 5 squared plus b squared, I'm going to end up finding out that this b is 12, and since the way it's written, I'm going to make it a -12. To do u, that was u. To do v, also in the second quadrant, they tell me the cosine is 3/5. They tell me it's negative, so this is going to be a 3. Hopefully by this point you're recognizing a 3, 4, 5 triangle, so this would have to be a 4. So those are my two angles that I have. So if I want to look at this, it told me that the sine of u was equal to 5/13. And then by looking at this triangle, I know the cosine of u is equal to -12/13. Looking at the other triangle that I drew, they told me that the cosine was -3/5. This of u, and so the sine of v, that's a v, is going to be 4/5. So I'm just going to write those down. And now for 35, they want the sine of u plus v. So for 35, we want to find the sine of u plus v. So we're going to use the sum formula. We're going to use this formula right here, and we're going to go ahead and plug those in. So it says the sine of u, I'm just going to write this down, times the cosine of v plus the cosine of u times the sine of v. And I wrote all those values up here, so I'm just going to use those. So the sine of u is 5/13 times the cosine of v, which is -3/5. Here's that plus sign. The cosine of u, which is -12/13, times the sine of v, which is 4/5. So this will be -15/65, and then this will be plus a -48/65. And when I add those together, I get -63/65, and that is the sine of u plus v. And real quick check, it has to be between -1 and +1. It can't be anything larger than that. So that's all at 1 and 1, the sine of u plus v. Now I'm going to go ahead and find the cosine of v minus u. So I'm going to try and squeeze this one up here where I can still see my values. So I want the cosine. So the cosine of v minus u will be the cosine of v, because I changed the order of v and u here, times the cosine of u, and then this will be plus the sine of v times the sine of u. So then when I go to do this, the cosine of v is going to be -3/5. The cosine of u is going to be -12/13. The sine of v is going to be 4/5, and the sine of u is going to be 5/13. So when I multiply, I'm going to have a negative times a negative, so it's going to be positive 36/65 plus 20/65. So my answer will be 56/65, and that is my final answer for 36. Okay, the last two problems ask us to verify the identity using the sum and difference formula. So 63 has a sine of pi/2 plus x, and I'm trying to show that that's equal to the cosine of x. So I'm using the addition. So I'm going to say the sine of u, which I'm going to make that pi/2, times the cosine of x, and plus the cosine of pi/2 times the sine of x. So that's just using the sum and difference formulas. And then I'm going to put in what I know. So the sine of pi over 2 is 1. So this will be 1 times the cosine of x plus the cosine of pi over 2 is 0. So 0 times the sine of x. But when I forgot to write that, we're trying to show that this is equal to cosine of x. So now I'll have 1 times cosine of x, which is cosine of x, and 0 times sine, which will be 0. So I'm going to end up with cosine of x is equal to cosine of x. So I verified the identity. Remember, you're not allowed to add, subtract, multiply, or divide anything to both sides of the equation. 68 is the same thing, except for I'm doing cosine of x plus y plus cosine of x minus y is equal to 2 cosine x, 2 cosine y. So let's separate it. I'm going to try and color code, see if that'll help. So this cosine of x plus y will be the cosine of x cosine of y minus the sine of x sine of y. And now I have this plus, so I'm going to put plus sign, and now the cosine of x cosine minus cosine of y. So this will be cosine of x cosine y, and then be plus sine x sine y. And I'm trying to show that that's equal to 2 cosine x cosine y. So when I do this, I have 1 cosine x cosine y, and I have another cosine x cosine y. So I have 2 cosine x cosine y, and then I have a negative sine x sine y and a positive sine x sine y. So those will equal 0. And I'm trying to show that that's equal to 2 cosine x cosine y. So the left side looking like the right side, so I verified that identity. And that is the end of your classwork, so I hope this helps, and we'll see you next time in class.